You've probably never heard of ruthenium, but it's quietly changing the way we make medicines and clean energy. This rare, silvery metal isn't just a footnote in the periodic table. It's a powerhouse in chemical reactions. It's not just used in labs anymore. It's at work in the very processes that power our world. Today, we're diving into the weirdly fascinating role of ruthenium in catalytic reactions and why it's a game changer. So, what exactly are we talking about? Ruthenium is a transition metal, part of the platinum group, found in the Earth's crust in small amounts. It's not as common as gold or silver, but it's incredibly valuable in its applications. Unlike many metals, ruthenium has a unique ability to change its oxidation state. This means it can act as both an oxidizing and reducing agent, which makes it versatile in chemical reactions. In catalytic reactions, ruthenium acts as a catalyst, speeding up chemical processes without being consumed. Its role is often critical in reactions that require precise control over electron transfer. Ruthenium is especially important in hydrogenation reactions, where it helps convert unsaturated compounds into more saturated ones. This is crucial in the production of fuels and pharmaceuticals. Its unique properties also make it a key player in electric catalysis, where it's used to improve the efficiency of fuel cells and other energy technologies. You might not think about ruthenium when you're making coffee or driving to work, but it's quietly doing the heavy lifting in the reactions that power your world. Every time you charge your phone or power a car, ruthenium is part of the chemical reactions that make those processes efficient and sustainable. It's not just about the big industries. It's also in smaller, everyday technologies that you interact with without even knowing it. So while you might not recognize it, ruthenium is quietly making your life better, greener, and more efficient, without you ever having to think about it. Back in the early 1900s, scientists were just starting to understand how metals could speed up chemical reactions. Ruthenium was one of those rare elements that caught their attention. But it wasn't yet known for its catalytic power. By the 1920s, chemists began to experiment with ruthenium in various compounds, trying to unlock its potential in industrial processes. It was still a bit of a mystery, but its unique electron configuration hinted at special reactivity. The 1960s and 70s saw a surge in interest as scientists realized ruthenium could be used in selective oxidation reactions. Its ability to switch between oxidation states made it a powerful tool in organic chemistry. Today, ruthenium is used in advanced catalytic systems, from fuel cells to pharmaceutical synthesis. Its role in making reactions more efficient and selective continues to evolve with new research and technology. Imagine you're making a lemonade stand, but instead of lemons, you're mixing chemicals. Ruthenium is like a super helper that makes the mixing go faster and smoother. When you add a little bit of ruthenium, it's like giving your lemonade stand a turbo boost. It helps the chemicals react without getting too hot or messy. It's like a magical middleman that makes the whole reaction happen quicker, without being part of the final product. Because it doesn't stick around, it can help make a lot of reactions happen over and over again, like a superhero with endless energy. So, even though you can't see it, ruthenium is like the invisible hand that helps your chemical lemonade stand run smoothly and quickly. To begin, we need a controlled environment where ruthenium can interact with the reactants. This means setting up a reaction vessel with precise temperature and pressure controls. Inside the vessel, we introduce a solution containing ruthenium in a supported form, like on a metal oxide surface. This allows it to be both reactive and stable. The reactants, like hydrogen and oxygen, are then carefully added to the vessel. Their concentrations are optimized to ensure a balanced reaction without side effects. A catalyst like ruthenium doesn't get consumed in the reaction, so it remains available to facilitate further reactions. This is why it's so effective in industrial processes. Before starting the reaction, we ensure all equipment is calibrated and the system is inert. Safety is always our top priority. Once the ruthenium catalyst is activated, it forms a temporary bond with the reactants, creating a highly reactive intermediate state. This bond is crucial because it lowers the energy barrier needed for the reaction to proceed. This intermediate state is unstable and highly energetic, which makes it much easier for the reaction to proceed in the desired direction. The ruthenium acts like a switch, facilitating the movement of electrons between the reactants. After the reaction completes, the ruthenium catalyst returns to its original form, ready to be reused. This regeneration is key to its efficiency in catalytic processes. This cycle repeats many times, making ruthenium an ideal catalyst for reactions that require high efficiency and minimal waste. Its ability to cycle through these states is what makes it so powerful. Now, the clever twist comes when the ruthenium center starts to shift its oxidation state, which subtly changes the electronic environment around the substrate. This shift is not just a change in charge. It's a reorganization of the bonding that opens up new reaction pathways previously inaccessible. By altering its oxidation state, ruthenium creates a temporary low-energy transition state that the reaction can easily pass through. This subtle change is what makes ruthenium so effective. It doesn't just facilitate the reaction, it guides it with precision. This clever twist is the key to ruthenium's role in catalysis, turning a complex chemical process into something efficient and highly selective. At the heart of ruthenium's catalytic power is its unique electron configuration. With a D-block metal, it can easily switch between oxidation states, making it a versatile mediator in chemical reactions. These oxidation state shifts allow ruthenium to donate or accept electrons in reactions, acting like a shuttle that drives chemical transformations forward without being consumed. The catalyst doesn't get used up. It just provides a low-energy pathway for the reaction to proceed, making it both efficient and sustainable. Ruthenium's true magic lies in its electron density and coordination chemistry, where it forms strong bonds with reactants, stabilizing intermediates and accelerating the reaction rate. Understanding these subtle interactions helps chemists design better catalysts, which are vital for everything from fuel production to pharmaceuticals. Imagine you're hosting a dinner party, and you need to serve a huge meal to a bunch of guests. You have one serving spoon, but you're serving dozens of plates. That spoon is like ruthenium. It doesn't get used up, it just helps move things along. Now, instead of food, we're talking about chemical reactions. Ruthenium is like that spoon. It doesn't eat up the ingredients, it just helps them react faster and more efficiently. So, even though the spoon is doing the heavy lifting, it doesn't disappear. It just keeps helping over and over again, like a good host who's never tired. This is the magic of ruthenium. It's not the star of the show, but it's the one making sure the show runs smoothly and efficiently. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.